Hey guys, Mr. Marone here, welcome back. So today we're going to look at our second of 3 videos in our trigonometry unit. And what we're going to focus on is more of the applied side of trigonometry today. And that starts with an idea of the angle of elevation. And an angle of elevation is the angle formed by the horizon and the line of sight upward. So formed by what's called the horizon line. Or if you were to look out onto the horizon, like say at the beach or something like that. So it's the line, the horizon line and the line of sight upward. So the line of sight up. So in our picture here, our angle of elevation is angle 1, where the horizon line is the C, and the guy looking up at the plane would be that elevated line of sight. So think of when you see the word elevation that we're rising something or we're raising it. So think of elevation equals up. Okay, think of that as we work through this. Because the other type you're going to look at are what are called the angle of depression. Okay, depression meaning to go down. And this is the angle formed by that horizon line and the line of sight downward. So the horizon line and our downward sight line. Okay, so for instance, the angle of depression would be from the plane looking down towards the man. Okay, that's the big difference. And if we look at our next two pictures over here, you can see there's an error in this first one because we were calculating just looking down and using the building itself as our other reference point to create the angle, where in fact the angle of depression sits at a horizontal, so you could draw a straight line off of that person and then from there down to the car, create your angle of depression. And the cool part about this is that if I were looking from the car up at the person, this would be my angle of elevation. And if we notice, the line of sight or our horizon line is always going to be parallel with the ground. So our angle of elevation and our angle of depression will be congruent. They are alternate interior angles here. So angle 1 is congruent to angle 2 with these. So just something to keep in mind as we work through. And this right here in our middle is the most common error that happens, having that wrong placement of the angle of depression. It's very easy to see the angle of elevation. The depression angle can be tricky. So I'm going to take a second here and look at a couple of these pictures and look at certain scenarios that you'll generally see as we work through these. Okay, so you're going to think of, a ladder against a wall, and they always refer to the foot of the ladder. Okay, that's the bottom of the ladder. And we always assume that there's a right angle here, which allows us to do right triangle trigonometry. Okay? The other one that you see a lot is a man flying a kite. So our string catches the kite. We refer to the distance from the ground to the kite as the height. And the distance between the kite and the guy would be the horizontal distance. Okay, thinking horizontal is left and right. And the other one you'll see is when we use a wire to kind of help support a tree. You've got your wire, and you've got the height of the tree, and generally right down here we refer to that as the stake holding the wire in. Okay, so these are 3 really common pictures that you'll see. The other 2 that you might see would be something like this, where you've got the sun coming down and hitting a guy. So we've got the height of the guy, and this down here along the bottom would be the person's shadow. So we'll refer to their height and their shadow, and both are caused by the sun's rays. Okay, so something to keep in mind there as we work through this. And our last one would be the plane looking down at the ground. So remember that when we have a plane, the horizontal line that's parallel to the ground creates our angle of depression down here. So our angle of depression is in here. Goes right in there. Okay, and this would be our line of sight for this picture. So between our horizon line and our line of sight is the angle of depression, and we refer to as the height of the plane as an altitude. Okay, we refer to altitude whenever we're dealing with our plane or anything that's flying up in the air. Okay? So now we've got a couple real world examples here that we're going to go through. I'm going to lead you through the first one, and then I'm going to just kind of briefly discuss 2 and 3, and then I'll give you the answers for 4, 5, and 6 for you to review. So here we're saying that a 3.4-foot guide wire is attached to a tree 3 feet from the ground. So if we refer to our picture of the tree, we've got a good diagram to work off of. So we're going to draw our tree, and once again, there's no judgment here. So there's my terrible tree, and here's the ground, and we said that there's a wire that's attached right there, and they said that the tree is 3 feet from this wire, and they said that the wire is 3.4 feet. And they want to know the angle formed between the wire and the ground. So we want our theta there. So if we were to just use this as a right triangle, straight across from my angle is the tree trunk. That's my opposite side. Across from my right angle is my hypotenuse at 3.4. And my adjacent side is at 3 feet. So with adjacent and hypotenuse, I'm going to use cosine. And we're looking for the angle. And that equals my adjacent side 3 feet over my hypotenuse 3.4 feet. And in order to find the angle, when we're just looking for the angle itself, we're going to use the inverse. So we're going to take cosine of -1 on both sides. So I've got cosine -1 of theta equals cosine -1 of 3 over 3.4. And when we plug that into the calculator, our theta is approximately 62 degrees. Okay? So once we have the picture set up, it's just a regular trigonometry problem like we've had experience with. Here's number 2. And once again, we've got the ladder leaning against the wall. So I've got my wall, and I've got my ladder. And there's the ground, there's my right angle. And it says the ladder is 15 feet tall, and it leans against the wall at a 52-degree angle. And they want to know how far from the wall is the foot of the ladder. Remember, our foot is down here. So we're looking for this measurement here. And if we were to take that into account, straight across from the angle is opposite. Across from the right angle is my hypotenuse. And I've got my adjacent side. So we're going to use cosine again. Only this time we have the angle. And that's going to be equal to x over 15. We're going to multiply both sides by 15. And I have 15 times the cosine of 52 degrees for x. And when we plug this into our calculator, we've got x is approximately 9 feet away. Okay. At this point, I'm going to invite you to pause the video and try number 3 on your own. When we return, I will have number 3 illustrated for you. And then we will illustrate 4, 5, and 6 for you to review. And then you can jump into some practice with this. Okay, welcome back. So here we are talking about the sun's ray striking the ground at 55 degrees. So what you could really do is have your horizon line drawn in and have that 55-degree angle down to the ground. But I moved it down to our bottom area in order to get it inside of our triangle here to work with it, knowing that we've got alternate interior angles there due to these parallel lines. And after all was said and done, I ended up with 30 meters after solving out for x. Okay. Here are numbers 4, 5, and 6 for you. Once again, I've drawn a little bit of a picture for each one, as well as the answers, and I ended up getting 56 feet for the first one, 37 degrees for theta on the second one, and 11,200 feet approximately for the third one. I'd recommend pausing the video at this point if you'd like to see these examples further and look at them in a little bit more in depth. Otherwise, I would invite you to go try your homework this evening and see how you do.